that pays to show their ads. Another important entity is the publisher. So the publisher is the website that actually shows the ad to the user. So typically, the publisher is compensated for doing so. And if you go to the online advertising literature, you will also see this word as well, the word ad tech. So this is a short, an abbreviation for any entity that helps optimize or help match the publisher to the advertiser. So example of these include Google Ads or Amazon, Meta, Criteo, and so on and so forth. So for the simplicity, for the purpose of this talk, I will not focus too much on the ad tech. So we'll just assume that for simplicity, that the advertiser go directly to the publisher and pay the publisher to show their ads. Okay, so those are the main entities. And in terms of the events, there are two main things to keep in mind. The first one is the impression. So impression is an event indicating that a user interact with an ad. Typically, this means that the user view an ad or the user clicks on an ad. And another important event is the conversion. So conversion is any action that is deemed to be valuable by the advertiser. So typically, this could be the user going to the advertiser's website and buying some product or service. But it could also be some other predefined action, such as installing an app or subscribing to some mailing list or something like that. Okay, so those are the basic terminology. So let's see some concrete example here. So let's say we together open some company. Let's say our company is selling toasters, and we have this toaster company, and the toaster company has a domain toaster.example here. So we go and place ads on a bunch of publishers, and then there is a user who go and visit one of these publishers, let's say publisher1.com, and they see our ad, maybe it's some banner ad at the bottom of the page. And then they go again on some other publisher.com web page, and then they see our ad again, but maybe this time it could be a different ad, maybe it's a different page, so we are showing now some kind of video ads. Okay, and then this can go on and on. So maybe they will see one more ad, one more banner ad. And then after all this, the user sometime later decides to go on our website and buy our toaster. So in this case, since the toaster company is the one paying to show the ad, we are the advertiser. And the publisher are the website that are showing these ads. So in this case, it's the publisher1.com. And each ad that is shown to the user can be considered an impression. And finally, the action of the user buying a toaster is considered to be the conversion. So now we are this toaster company, we pay some money to show this ad to the user. There are certain statistics that we would like to know so that we can adjust and perhaps improve the performance of our ads. And perhaps the two most basic metrics are the reach and frequency. So reach is just the number of unique users that our ad reach, the number of unique users that see our ads. And for frequency, the K frequency is the fraction of users that see the ads exactly K times among the users that see the ad at least once. And sometimes the greater than or equals to K frequency is also considered as well. So this is kind of the cumulative version of K frequency, where we count all the users that see at least K ads, not just exactly K ads. Okay, just a basic example here. If there are 4 users, the first user see the ad once, second doesn't see the ad at all, and the third and fourth user see the ad twice, then the reach will be 3 because all but the second user see the ad. And then in terms of K frequency, the one frequency would be 1/3 because exactly 1 out of these 3 users see the ad once. The second bucket would be 2/3, and the remaining bucket would be 0. And greater than or equal to K frequency would be 1/3, 1/1, for example. So these are very basic statistics that have been used to measure ads performance even before online advertising, and it remains an important metric in the online advertising age. So if we are an advertiser, we may want to go and measure the reach for our entire ad campaign, but maybe that's not fine-grained enough for us. Maybe we want to slice the query further to get a more fine-grained result. For example, we could slice based on the geographic location, so reach of the ads based on the states that people are in, like in Massachusetts or California and so on. And maybe we want to slice further based on the age of the user and so on and so forth. So in this example scenario, you can see that these queries form a hierarchical query where the slicing become more and more fine-grained. So as you can see here, this is a pretty similar setting as what we have seen in differential privacy literature, including application of differential privacy in the census setting as well. So it's not too far away from what we typically do already. Okay, so those are the two basic statistics that you might want to know, reach and frequency. But that's not the end of the story. What you might want to know even more is how does your ad influence the user behavior to go and actually buy your toaster, right? And this leads us nicely to the idea of ads attribution. So in the example that we saw earlier, the user saw 3 ads before converting, before buying our toaster. So here we would like to understand among these 3 ads, which ad is the most important and which one is the least important in influencing the user to go and buy this toaster. And the idea of ad attribution is to try to assign some weights to these ads based on how important they are in influencing the user to convert. And this is typically based on some attribution logic rules. Some of the most popular rules are as follows: last touch attribution, or LTA. This is as its name suggests, this is a very basic rule where you assign all the credit to the last ad. So in this case, the third ad would get all the credit and the remaining ad gets 0. There is first touch attribution, which is the opposite. You assign all the credit to the first ad and 0 to the remaining ads. There are also uniform, where you just assign the credit uniformly across all the ads. And note here that in the uniform case, since you assign the non-zero credit to more than one ad, this is sometimes called the multi-touch attribution. Whereas in the previous case, where you assign non-zero credit to only one ad, this is called single touch attribution. And among the multi-touch attribution, there are also many other ideas, such as exponential time decay. So you can assign the most credit to the most recent ad, but also still assign some credit to the previous ad, but the weights decay with time. And yeah, another popular one that has been used a lot recently is a data-driven attribution, or DDA. So in DDA, you go and train some model that would give you the weight. And once you have the impression and conversion, you just put this into the model, and the model will be the one assigning the credits for you. So for the simplicity of this talk, we'll be focusing on just single touch attribution. And in particular, for any concrete example, we will just use the last touch attribution, which is assigning all the credit to the most recent ads. And here I want to stress that even if we do single touch attribution here, the attribution process can involve multiple publishers. So in this example, it could be that the second ad that the user sees is not on publisher1.com, but is on publisher2.com. Okay, so this process, even though you are assigning credit to only one ad, you can be multiple ads across multiple publishers can be considered here. Okay, so that's a very quick introduction to ad attribution. Now, what would we like to know from this ad attribution? So again, we would like to make some aggregated queries to this attribution logics. Some of the important queries are conversion rate. So this is the percentage or fraction of the views or the clicks, or like fraction of the impression more generally that leads to the conversion. You could also be asking for the average conversion value as well, or the total conversion value. And again, this can be sliced and can be hierarchical query similar to reach and frequency setting. Just to give you an example here, maybe you want a total conversion value across all the campaign, and then total conversion value for people in Massachusetts and in California, and then for Massachusetts, certain age group, and so on and so forth. But not only do you want the aggregated statistics, sometimes it's also important to have event level statistic as well. And an example here would be for each impression, you actually want to know exactly how many conversion it leads to and what is the total conversion value. So why are these so important for online advertising? This statistic can help influence business decision. For example, if you see that the ad is more effective in certain region, maybe you want to increase the budget in that region. And if it's less effective in the other, maybe you want to decrease the budget. And meanwhile, the event level statistic is very important to build a machine learning model to predict conversion rate and conversion values. And these models are important because these models tell you roughly how much you want to pay for your ad to be shown. And this value is used, for example, when you bid for an ad in automatic ads auction. So this is a very quick rundown on how attribution is done and why it's useful for the advertiser and also publisher. So now I will switch gear and start talking about privacy. So as you can imagine, we are talking about releasing statistics and machine learning models. So there are already privacy risks associated to those. If you slice too much, or if you use the event level report, then you could be talking about using information of individual users. So that can be pretty damaging in terms of privacy. But also another concern is that currently the tools that is used to do attribution right now is also not really privacy preserving. And in particular, I will talk about this tool next, which is called third-party cookie. So just to remind you very quickly what cookies are, let me start with the first-party cookie. So first-party cookie is, let's say you visit some new website like full1.com. The first time you visit this website, you send some request to the site, and then the site can return back to you some cookies. And when you visit the site again, this cookie will be sent to this site, who can then use the information in the cookie to help personalize your experience. And this goes on and on. So this first-party cookie is very useful in session management. For example, when you log in, this could contain a token so that you don't have to log in every time you wanna, access your email, for example. And this is called first-party cookie because this is the cookie that is given to you from the website that you actually go to, right? So this is cookie from full1.com, which is the site that you actually visit. Okay. Now that's first-party cookie, and that's not what we are concerned about. What we are more worried about is about third-party cookie. So what is third-party cookie? So let's take a look at the example we already looked at before. So when you visit a website and you are shown an ad, these ad banners or video ads can send a request to the advertiser. So in this case, the ad can send a request to the toaster.example. And the toaster.example can now send a third-party cookie back to you. And the next time that you see an ad from toaster.example again, this third-party cookie is sent to toaster.example. And this process continues. So from the advertiser perspective, this is great because they can determine exactly the set of impression and conversion that you have had so far. So this allows them to compute the reach and frequency and also do the attribution as we said earlier. And this allows them to do these measurements. So that's great for them. But as you can imagine, this can be very easily abused, right? Because if someone managed to put some script or some ad across many and many websites, they can more or less construct some partial history of your browsing history. So that is very bad, and we don't want that. And before I continue with this, I want to quickly mention that this third-party cookie is just an intermediate tool that the advertisers or publisher are using to do ad measurements. Is not the end goal, right? The end goal of the publisher or advertiser are still to try to optimize their ads, to try to make business decisions based on these measurements. And this end goal, this business decision, you want to make it so that it's still pretty robust to outlier, right? It shouldn't change arbitrarily if some single user makes some arbitrary decision. So in some sense, in terms of the end goal, at least at a high level, this ads measurement is not contradicting with privacy. Okay, so there are privacy and ads measurement, at least at a high level, are consistent and they should be able to go together. It's just that the way they are doing it right now is opening themselves to this privacy risk. Okay, and with this in mind, there have been a lot of effort in terms of reducing this privacy risk. And one of the biggest one is the phasing out of third-party cookie. So some of you might have already heard about this, but in some browsers such as Safari or Mozilla Firefox, it's already turned off by default. And for Google Chrome, it will be turned off in 2024. Now, this is great for privacy, right? Third-party cookie will be gone. That's good. But at the same time, it also breaks many of these valid use cases, including the use case of ads measurement. And what this means is that there are multiple proposals that are being put forward right now to create APIs that will allow this use case to continue in a more privacy-preserving way. And today we will discuss some of these. And in particular, we'll just focus on measurements, on those that are on the proposal that are specifically for measurements. Even for measurements, there are already many proposals, such as the private click measurement or PCM by Apple, and there is the attribution reporting API or ARA by Google, which is the one that I'm gonna talk about more concretely when I give a specific example. There are MassLark from Microsoft. There is a IPA jointly from Meta and Mozilla, and there is also the most recent one, private ads measurement or PAM from Apple. And some of these are limiting the privacy risk without using DP, and the others are using DP. So our focus will be on the ones that are using DP here. And I would like to mention that this is only for measurements, right? There are also other use case of third-party cookie, other valid use case of third-party cookie, like targeting or fraud detection, that also require different APIs as well. So we will not be discussing that in this talk, but if you are interested, I have a link here. You can check out the W3C GitHub repo for more. You might have heard about topics API or private state token API and so on. So those are listed there, but we will not be discussing it here. Okay, and also before I go forward, let me say that you shouldn't take any of these proposals as being final, right? These are still very much ongoing work. And indeed, I hope that this talk will be an invitation to some of you who are interested in learning more to go and check out, look more, and maybe come up with more novel and better solution in this problem space. Okay, so with that in mind, let's go to the privacy part. So I don't think I have to do a review on differential privacy, since this is TPDP. But of course, we have the central model where the algorithm get to see the raw data and only the output needs to be differentially private. And here, the only algorithm we'll be discussing is the Laplace mechanism, where we add noise proportional to the L1 sensitivity. I'm sure everyone already know that. And also, of course, we have the local model where the data lives on device and all the messages that leave the device has to be differentially private. And in this case, the most basic algorithm is the randomized response, where with certain probability we output the true value and otherwise just output a random value from the universe. Okay, so now let me give you a very high level overview of these proposal of these APIs that have been proposed. And we can classify these APIs into two categories. The first is the aggregate APIs, where the output are aggregated statistics, and the second is event API, where the output are event level statistics. So the high level of the different aggregate API is as follows. First of all, since your device or your browser actually get to see all the impression and all the conversions that you do, you can already do attribution on device, or in other words, inside the browser itself. Okay, and this is basically what all this proposal is trying to do. So let's say you are a user and you have a device and you see a bunch of impression and conversion. Then your device or your browser can record this, and then the attribution itself can be done on device directly. Okay, so you don't have to send any request to the advertiser to do this part. Once this is done, what this proposal say is that they will allow the advertiser to specify how to encode this attributed data set into some histogram contribution. And this histogram contribution will be capped with certain L1 or L2 sensitivity, so that we can get a privacy guarantee. These histogram contribution are then sent to some aggregation service. And again, different proposals have different ways of implementing this aggregation service, which I'm not going to go into detail. But this aggregation service will sum up all these histogram contribution and add some noise, so that at the end you get some DP histogram back. And this DP histogram is what is going to be revealed to the advertiser at the end. Okay, so this is a very, very rough, high-level overview of this proposal, like without going into too much detail. So just to give you a concrete idea of how this proposal can be used, let's take a look at the queries that we already saw earlier. Let's say you want to know the conversion value for the entire campaign, and then for Massachusetts, for California, and then slice further and further. Then you can just create one bucket per each query, right? So now let's say this user is from Massachusetts and is of age 25. Then you can have one bucket for the entire ad campaign, one bucket for each state, and then one bucket for each combination of state and age group. And since this user is from Massachusetts and has age 25, then this user would only contribute to the all bucket, the bucket for the entire campaign, the Massachusetts bucket, and then the specific age group that this user is in. Okay, so that's very simple, right? You will give this histogram contribution, it gets summed up, and then you get exactly the answer of these queries that you want. Of course, with noise. Okay, now I want to just to give you a more concrete example. I want to be a little bit more specific by looking at the attribution reporting API or ARA. This is a proposal by Google. In the ARA proposal, the capping is based on the L1 sensitivity, and the capping is done on a per impression level. So for each impression, you can specify the histogram contribution, and the histogram contribution has to have L1 sensitivity at most certain big delta here, and in the API it's set to be some fixed value like 2 to the 16, but it's not too important for the purpose of this talk. And eventually what you do is you add some Laplace, what the aggregator do is that it adds a Laplace noise scale by this delta over the epsilon. Okay, so this is just an example of how of like a specific implementation here. And as you can imagine, this API is somewhat generic, but also not too generic. And you can still do certain optimization for this API. For example, for different query, you can try to assign different privacy budget for each different query by just rescaling the query before and after. Like for example, for each bucket I, if you wanna give a privacy budget AI to it, you can scale it up by a factor of I, and then you rescale it back after the aggregation. So this is equivalent to assigning a privacy budget of AI to this particular query. Yeah, for example, here I could rescale the smaller query more if I want to if I want to give more budget to them. And of course, you can also do post-processing here as well. Like if your query have a certain linear constraints between them, then you can post-process and get a better accuracy. This is again very similar to what is done in DP literature already and also in the census setting. So for example, if your parent is equal to the sum of the children, then you can take a linear combination and reduce the variance. And as some of you might have noticed, this is also a specific instantiation of the metric mechanism. And so you can also try to implement the more complicated metric mechanism in this setting as well. Okay, so those are some tricks that you can apply even today to optimize the accuracy for ARA for this aggregate or like summary reports. But there are still multiple challenges here. One thing is that it's kind of hard to align the objective that you want in terms of the error to the downstream task. For example, one thing that I have seen from my experience is that sometimes people want to measure the error in terms of relative error instead of additive error, whereas most of the literature in our field has been focusing mostly on additive error, like in metric mechanism, for example. So it would be nice to expand those and understand more for other type of error. Similarly, to optimize the budget, sometimes you need historical data to understand how to scale the different budget according to the different query. And that can also be challenging if you are running your first campaign, for example, you wouldn't have this historical data. There are also time delay. You can get a report very often, but if you get a report too often, then it would be too noisy because you have to add noise for every single report. Or you can go the opposite end and you can wait for a long time and get the report, but then you have a lot of delay, and maybe that's undesirable because it takes a longer time for you to react to any signal. And as I said earlier, the API is still pretty basic. It's just literally just histogram and summing them up and returning you a noisy histogram. So it cannot implement some other more complicated algorithm, even exponential mechanism or sparse vector technique or proposed test release. So it would be nice if someone can come up with an API that is easier to use, that is both easy to use and also encompass these other more complicated, more advanced algorithms as well. Okay, so that is aggregate API. Now I will also quickly talk about the event level API. So again, event level API are the API that try to return for you event level report, right? Not just aggregated, but report for every single event. Okay, and the first step is similar to before. So again, the attribution happens on device, but then you would somehow discretize this attribution information into some small finite space, and then you do randomized response. And this the result of the randomized response is what you send to the report collector, which is then shown to the advertiser. So just to give you a concrete example, in the ARA event level report, the randomized response is applied at the impression level. Now there can be multiple conversions attributed to each impression, and it can also correspond to different reporting time window as well. So for example, if we say reporting time window is 1 day, 3 days, 7 days, it means that there will be report sending 1 day after impression, 3 days after impression, and 7 days after impression. And for each impression, we cap the number of conversions that can be attributed per each impression. And for each conversion, the advertiser can choose to specify certain number of bits, in this case, no more than 3 bits, to include some information about that particular conversion. Okay, and this is called the metadata of that conversion. So as you can imagine, there are actually quite a lot of states here, because for each impression, you can have this many conversion, and each conversion, you can have this many metadata, and each conversion can also correspond to different reporting window. So if you do this like star and bar style counting, you will see that the number of reports is the number of possible states for each impression is quite large. But that's roughly the main idea. So just to give you an example, let's say that we have reporting window 1 day, 3 days, 7 day, and let's say we have this sequence of impression and conversion. So the first impression happened on day 1, second conversion, the first conversion happened on day 1 as well, second conversion happened on day 7, and then the second impression happened on day 3, and the third conversion happens on day 3. In this case, if we do last touch attribution, the first 2 conversion will be attributed to the first impression, and the last conversion is attributed to the second impression. So now, as we said on the right, each impression will now have this state on which we will apply the randomized response on. For the first impression, the state would be these 2 conversions, including the reporting window and also the metadata that they have. And then you apply randomized response on each of these attribution information that is attached to each impression. So in this case, for example, maybe we flip the coin and we say that we will keep the data for impression 1, whereas for impression 2, we will completely randomize it. So the impression 2 gets randomized. And then these are the information that gets sent to the report collector and also to the advertiser. Okay, so I know it's a little bit abstract at the moment. So let me just very quickly show you how this API can be used. Just to give you a quick example, like suppose you want to train the model that predict the conversion rate after 1 day, conversion rate after 3 days, and conversion rate after 7 days. Then you can use this API where you don't have to set the metadata at all. And then what you get at the end out of the API for each impression is a noisy information of whether that impression leads to a conversion within 1 day, 3 days, and 7 days, right? So for each impression, now you have a training data where you have a pair of impression and whether it leads to a conversion within 1 day, 3 days, or 7 days, where this is a noisy information. And then you can use this training data with noisy label to train your ML model. And the same goes with if you want to do conversion value instead of just whether there is a conversion. In the case of conversion value, now it becomes a little bit more complicated because you have to discretize your value into this 3 metadata bit that is allowed by the API. So one way you can try is to bucketize your value. And then in this case, your metadata would be the value bucket. And then again, you can do very much the same thing as in the previous slide. Okay, so those are the very high level ideas of the event level API. Yeah, so yes, so some of the challenges include the fact that sometimes even when you try to, it's hard to relate the randomized response directly to the performance of the model that you get at the end. So it would be nice if we can understand this relationship better. One thing I would like to also point out is that this event level API is actually can be thought of as a subset of label differential privacy, where the idea is that the input, there is an input data set and we don't have to protect the feature, the XIs, but we want to protect the labels, the YIs. And in this case, we say that the 2 data sets are neighbor if they differ by a single labels. And in our setting, the XI are the impression, the feature of the impression, whereas the YI are the conversion count or the conversion value, which we have to discretize and apply randomized response on. And for label DP, there are actually more advanced algorithms than just applying randomized response. But currently, this is not supported by the event level API. So it would be nice if someone can come up with an API that can support those more complicated algorithms while still being widely usable. Okay, so the very last topic of this talk is to talk about the formal DP guarantees. As you can perhaps notice, I have more or less skirt around actually saying what DP guarantee this API give you, because it is a little bit complicated. So the first thing we have to answer is what is the notion of neighbors? How do we define that? How do we define two data sets to be neighbor? And we can start with some basic notion such as conversion level adjacency. So I say that two data sets are neighbor if they differ on a single conversion. Now, if you look at this in the event level report, it turns out that this worked out pretty well. Why is that? Is because each conversion, since we are in the single touch attribution, each conversion is attributed to a single impression. And we already apply randomized response on that impression. So we do get that this API satisfy conversion level DP, and in fact under local DP as well, because that's all that leaves your device. Okay, so this is the most basic one, and it's great. So let's think about this a little bit more. What if I change from conversion to impression? What if I say that two datasets are neighbor if I can change impression arbitrarily, change one impression arbitrarily? Well, if you look at this API, the impression information is revealed in the clear, right? We are only randomizing the metadata associated to that impression, but not the impression itself. So actually, this does not satisfy impression level DP. Okay, so is that a problem? Yeah, this is where the subtlety comes in with this kind of APIs. In this case, it doesn't seem like this is an issue. This is because the publisher and the advertiser are the one serving the ads to you. So they actually already know the set of all impressions. So you shouldn't be able to change the impression arbitrarily from one to the other. So perhaps a better notion of differential privacy here would be to allow you to move an impression from one user to the other user. And under this neighboring notion, this API does satisfy that impression level DP. And that notion corresponds more to what we are trying to protect here, which is we are trying to protect linking the user cross-site. So this notion of DP seems like an appropriate notion here. And this impression and conversion level DP are just two possible adjacency notion. As you can imagine, what you might want at the very end would be a user level DP notion, but there are a bunch of things in between, such as maybe you want to satisfy user publisher level notion, where you can change all the data between for any arbitrary user publisher pair. And there is a user advertiser notion similarly, and user publisher advertiser notion, and so on and so forth. And each of these has its own subtleties, which I will not go into detail here. The last subtlety that I want to discuss is regarding to the capping. So notice here that in the summary, the aggregate API, the capping is done per impression, but it is done after the attribution, right? Whereas the protection that we want for DP is for before the attribution, which is the actual user behavior. Now it turns out that this pre and post attribution capping can interact in very complicated way. So yeah, I don't think I have the time to go into this example here, but I will just show you this, that if we do post attribution capping, it's not necessarily giving us the DP notion that we want, and in particular for the case of impression level with last touch attribution is fine. The post attribution capping does give you DP, but in some notion they unexpectedly not give you DP, such as user publisher level notion or user publisher advertiser notion. So this subtlety is something that has to be taken care of when coming up with such APIs. Okay, so just to recap here, there are multiple challenges in actually obtaining formal DP guarantees based on these APIs that we design. In particular, for adjacency notion, we have to think about the fact that there are multiple parties here, the publisher, the advertiser, and although I simplified in this talk, there is also the ad tech. And these different parties hold different part of the information of the user. So this means that sometimes some notion that seem natural becomes unnatural in this setting, and we have to be careful. And also the different party can also interact in a non-trivial manner that has to be taken into account as well. And in terms of contribution capping, as I said earlier, the contribution capping can interact with the attribution logic in a pretty complicated manner. And we have to be careful as well on how to apply this and how to claim formal DP guarantees. Another thing that I didn't talk about at all is side channel leakage. Again, we are talking about real life deployment here. So there could be some other side channel leakage. For example, if your device is turned off during the time that you are supposed to send the report, and it turned back on later and you send the report later, then the time that you send the report could also be leaking some information. So this has to be taken care of as well. Okay, so yeah, so those are basically all that I want to talk about. So I will skip this one. Yeah, so let me just quickly conclude here. So today I tell you a little bit about measurements in online advertising, the privacy concern, and how we are trying to mitigate this privacy concern based on these different new APIs that are supposed to be more privacy preserving than the current existing solutions. And there are a few pointers if you want to learn more. Again, there is the GitHub repo of W3C where you can go and look at all the proposals around. And you can also join the WICG group to discuss more about this proposal. And you can also discuss every specific proposal on their specific GitHub website as well. And as I said earlier, I think ads measurement is a very important space that needs more experts to think about in terms of privacy, especially differential privacy. And I think it could have a pretty big impact. So I hope that many of you will take the opportunity to look around all these different proposals and maybe contribute towards some new and better solution. Thank you very much. Given that the current proposal is not getting at user level, got any experiments or background for population, would it be feasible to track user? Thank you, Salil, for the question. So the question is, given that the current proposal doesn't give user level DP, is there any experiment being done that shows that it can actually mitigate the cross-site attack that we want to mitigate? I'm not aware of a full experiment, but at least I know that there are back of the envelope calculations in terms of the information leakage. So we can compute the information leakage of the API, and then we can show that large-scale tracking wouldn't be possible, but we couldn't rule out tracking very small fraction of user.
I think you have one more.
I want to ask from Juan Yu online. Yeah, that's a question. Here's why Google thinks event conversion level DP instead of user level DP, which is a stronger guarantee than enough to put the justification for choice. Any reason we're confident the attacker cannot link many events together to implement the attack? Thanks.
Okay, so just to repeat the question and compress it a little bit. So I think the question is why do we use event level DP instead of user level DP? Okay, I should say, yeah, perhaps I should have said this and stressed this earlier. but none of this proposal is the final proposal, right? You should think of this proposal as a first step in trying to go into the right direction. Of course, in the long run, in the final form, in the steady state, we would like to go into a better notion of DP, such as user level DP. But this is the notion that we have to start with, while not completely breaking the utility.
Okay, let's thank us.